So this session will be about rusting. We should get it done in the single period. Okay, so this is related to oxidation and reduction because the rusting of iron is an oxidation reaction. If you look at the first page of the notes, now this is page 5 of the notes. Okay, so just to note, and it'll say in the video that I'm showing you in a minute, iron is the only element that rusts. Okay, all other metals react with oxygen and water as well, but that's corrosion. So rusting refers to iron or ferrous materials such as steel. Okay, now the conditions for rusting are that you need both oxygen and water present. Now just note that this is oxygen as in O2, right? Oxygen gas, either from the air directly or dissolved in water, and not the oxygen in the water molecule. Okay, the water can be just present in the air and can condense on the iron object, or you can just if you put an object into water directly, it'll rust more quickly. Now, the chemical name for rust you need to know. Okay, so it's hydrated iron 3 oxide, right? 3, remember, means, if you look in the back of your data leaflet, you see the iron 3 refers to the Fe3 plus ion. Okay, so in the rusting, right, the oxidation process is that the iron atoms in the metal lose electrons to form iron 3 plus ions, right, which becomes the iron 3 oxide. And remember that loss of electrons is oxidation. So the iron is oxidized to iron 3 ions. Okay, now what we look at next, if you just actually could, in page 6, there's a little error here. If you could scribble out the word oil under magnesium, that's just a typing error. Okay, so just please scribble that out. That should just refer to magnesium. Okay, we'll come back to this after the video. Okay, so let's play this. This has most of what you need.
Hi, welcome back to freesciencelessons.com. By the end of this video, you should be able to describe what's meant by the word corrosion. You should then be able to describe the conditions required for rusting. And finally, you should be able to describe how to prevent corrosion, including sacrificial protection. And all of this is for triple chemistries only. I'm showing you 3 different...
Ignore that, that means for the English boards, we just double the word.
...materials here. And in each case, you can see that the materials have been corroded. So we're going to start by looking at the definition of corrosion. And I'm showing you that here. Corrosion is the destruction of materials by chemical reactions with substances in the environment. Now, there are lots of different examples of corrosion, and a good example is rusting. The first thing you need to understand is that rusting only applies to iron and to alloys of iron such as steel. You must never use the word rusting when talking about metals other than iron or alloys of iron. In the case of other metals, you should use the word corroding. Now, in the exam, you could be asked to describe how to carry out an experiment on the conditions required for rusting. I'm showing you here 3 test tubes. In the first test tube, we've got an iron nail in distilled water, and the test tube is open to the air. In the second test tube, we've got an iron nail, and this is also in distilled water. However, this water is being boiled. Boiling the water removes any dissolved air.
That's a key point. If you boil water, right, water has got oxygen and all the other gases in the air dissolved in it. Sorry, water generally has, and if you boil it, they come out of the water. So boiled water has no oxygen present.
Be covered with oil, and this prevents any air in the test tube from dissolving in the water. In the third test tube, we've got anhydrous calcium chloride powder. This removes any water from the air in the test tube. We've also placed a rubber bung on the test tube, and this prevents any moist air from entering. So to summarise, in test tube 1, we've got water and air. In test tube 2, we've got water but no air, and in test tube 3, we've got air but no water. We now leave these for several days and then look for any changes. In test tube 1, we find that the iron nail is covered in rust. In test tubes 2 and 3, there's no rust, And this tells us that rusting requires both air and water. Now, corrosion is a big problem as it damages materials, but we can stop corrosion by using a barrier between the environment and the materials we want to protect. So to do that, we can use grease or paint, or we can coat.
Okay, I'm going to go back to the notes for this next part. So if you look at page 6 of your notes, okay, so just that first section, right, is about the investigation of the factors that cause rusting. So if rusting occurs, the why here is that both air and water, or both air/oxygen and water are present. Now, if rusting does not occur, right, it's because one of those is missing. Either air, oxygen, or water are not present. Now, we'll come back to this diagram again, but you can see here that in this first two, right, you've got an iron nail and a steel nail. Both are ferrous materials, so both would be could rust. And you've got water that nothing has been done to. So it will occur in both of these because you have both water and air dissolved in it. The important thing here is the role of calcium, anhydrous calcium chloride. So that should be anhydrous. Okay, if you put anhydrous calcium chloride anywhere near into the reaction, right, into the container, it's a drying agent and it will absorb water from the air. Okay, so that's its role. So if you have that present, there will be no water in the air. And the other thing to note is that boiling water removes dissolved gases, including oxygen. Okay, so if you have anhydrous calcium chloride present, you will have oxygen but no water. And if you have boiled water, you will have water but no oxygen. Okay, right, so in this one, right, really this is boiled water, just realized it's not labeled. Okay, and the layer of oil, if you caught in the video, that is to prevent oxygen dissolving back in after you've boiled it, boil the water. Okay, we'll come back to this one in a minute. This one here has calcium chloride. Now in the video it was down at the bottom, but it doesn't really matter. It'll just prevent, it'll absorb the water wherever it is. Okay, so that's the key parts there. And we'll go back to the video for the next bit, which is how to prevent rusting. So just be aware there are two methods generally. There's the barrier method and there's sacrificial protection. Barrier methods are pretty obvious. It's just covering the iron material with something that prevents contact with the air and water. Sacrificial protection is a bit more chemical, I suppose.
The material with a metal, and that's called electroplating. Aluminium is a very commonly used metal. The surface of aluminium naturally reacts with oxygen in the air to form a thin layer of aluminium oxide. This protects the metal underneath from any further corrosion. Now, there is one final way to prevent corrosion, and I'm showing you that here. This shows iron nails that have been coated in a layer of zinc. Coating the metal with zinc is called galvanizing. So these are galvanized nails. Firstly, the layer of zinc acts as a barrier against air and water, and this prevents the iron from corroding. However, if the zinc gets scratched, then it still prevents corrosion, and that's because zinc is more reactive than iron. This means that the zinc corrodes instead of the iron. Using a more reactive metal like this is called sacrificial protection, and you'll be expected to use that term in your own. This shows zinc bars on the steel hull of a ship. Again, because zinc's more reactive than iron, the zinc corrodes instead of the iron. The zinc bars are replaced every couple of years. Remember, you'll find plenty of questions on corrosion in my Vision workbook, and you can get that by clicking on the link above.
Okay, so that last bit about sacrificial protection, just the way he worded it in the video is exactly how you would word it in the exam. That he was saying about using zinc. Now, zinc is higher in the reactivity series than iron, so it will corrode in preference, or it will react in preference to iron. So that's exactly how you'd word it. Another metal that they often use is magnesium. I'm just trying to get this back. Okay, so if we share just the notes again, just see the key points there. Okay, so if you go to this, right, 224, the bottom page 6, you'll see that the first, as I say, straightforward method, so first of all, just to identify that rusting causes an iron object to lose its metallic properties. So it's no longer malleable and ductile, no longer has a high melting point, and so on. So you want to prevent that, right? If the metal corrodes, it becomes very brittle, because now it's not metallic, it's an ionic compound. Okay, just note that here for this barrier method, right, they have actually mentioned 4 on the specification. In the video, it talked about electroplating. So electroplating is the process of coating a metal with another metal, right? And it's called galvanizing if that metal is zinc, right? So galvanizing refers to zinc specifically. So you can coat one metal with another metal, right, to protect it, maybe a less reactive metal to protect it. But if you use zinc, which is actually more reactive, it's called galvanizing. Now, galvanizing is a form of sacrificial protection. So you can read this yourselves, just learn what it means. Okay, what is it? And what examples are there of it? The sacrificial protection would be the higher tier stuff. You need to know what it is, right? It's the use of a more reactive metal, right? One higher in the reactivity series. And all you have to do is attach it to the iron object, and it corrodes in preference to the iron. Now, if you go back to the video, you'll see that they actually showed the hull of a ship, and they just showed the bars of iron attached, the bars of zinc just stuck onto the hull of the ship. Now, you do not have to coat the entire object in the more reactive metal. That's the sort of amazing thing about it. You just have to attach it. And just the presence of that more reactive metal means that it will react or oxidize in preference to the iron. Now, the 2 metals that are mostly used for sacrificial protection are magnesium and zinc, okay? Higher in the reactivity series. And they are used because they're more reactive than iron and will react in preference to it. Okay, so let's have a look at how this works, right? Now, actually, go back to page 5, page 6, okay? And now, perhaps, when you look at this example, you'll see exactly why the nail will not rust in this picture here, right? So if you just wrap a wire of magnesium, now all it has to do, it doesn't have to completely cover it, it just has to be in contact with the iron. So if you put a piece of magnesium wire around the iron nail, that will prevent rusting, right? And the reason is that magnesium is more reactive than iron and reacts in preference to it. So that will happen, that magnesium will protect the iron until it all has reacted itself, and then you would have to replace it. Okay, that's why they prefer sometimes use zinc. Zinc is lower than the reactivity series than magnesium, so it'll last longer, it'll react more slowly than magnesium. If you use magnesium, it'll have to be replaced more regularly. Okay, so last bit of the notes here before you do questions is the diagram, page 7. Right, so here you have another demonstration of sacrificial protection. So in the first, so have a look at this and think, what's going to happen? Where will rusting occur in all of those? So rusting will occur in test tube 1 and test tube 2. Now in test tube 1, you have water that hasn't been boiled, so it still have oxygen in it. So when you have both oxygen and water, rusting will occur, right? And obviously the metal is iron. In the second one, you've used a less reactive metal in contact with your iron. Now that will do nothing, right? Iron is more reactive than copper, so it will react in preference to the copper. So the copper will not protect it. But in the third test tube, you will have no rusting because magnesium is more reactive than iron and reacts in preference to it. Okay, so what I want you to do now is there's questions on page 7, on page 8, and that is what you are to do now and for homework, and send me on page 9. Right, so they are the questions that you are to do between now and tomorrow.